So part D, what we've just shown, again, in each of these pieces, is that the sine of theta is approximately equal to theta when we use a linearization of zero. We've also seen with the limit kind of argument that as theta gets close to zero, the sine of theta is equal to one. So therefore, sine of theta is approximately equal to theta when we do some cross multiplying. So I nod in agreement and hopefully you did as well. So now let's go on to 7a. So in here, let's actually prove the statement, right? So if we look at what we're trying to find that sine of theta and theta. So the difference between these two things is less than 2%. So 2%, instead of writing 2%, let's write 2% as 0.02, just turn your 2% into a decimal. And the difference between them, well, that means that we want a distance. We've seen working with deltas and epsilons that whenever we want a distance, we can break out absolute values. So this is what we're trying to prove. We're trying to show that the sine of theta minus theta is less than 0.02, and we want to find where this is true. All right, so let's do this in Desmos. We can use thetas. I'm going to use x's in Desmos instead of thetas, although we could definitely type in theta. So my first equation, I'm just going to do an absolute value of the sine of x. Again, we could use theta minus x. And then, all right, so here's this part right there, sine of x minus x. And then I want to know when y is less than or equal to less than whatever, 0.02. All right, so notice that we have this kind of weird sine function there. It kind of looks like that. But we also have this inequality. So any values. Let's zoom in to see where we get this intersection, right? So if I zoom in enough, I can find 2 points of intersection for my function. I can see that we get 1 point of intersection at negative 0.49526 and one at positive 49526, right? It's an even function after all. So our solution set is going to be any place that's shaded between these two. So it's going to be all of these x values between negative 4.9526 and 0.49526. So these values of x. So we've shown that here, whenever theta is between 0.49526 and negative 0.4926, this is satisfied. That was a point 495. Yeah, cool. All right, so that's kind of point. So we found those values of theta. So just that's part A.